Hey, this is Miss Krupstad, and this is a video that's going to cover 763, which is on factoring completely. Notice those capitalized word is completely, all the way, doing all the types of factoring we know how to do. So in other words, what we're going to be doing is we're going to be factoring out the GCF and then factoring using the box method. So we're going to do both types of factoring today. So when you need to be aware of this is when you see a problem kind of like this. At first glance, you might say, oh, well, it's a trinomial. I can factor this, no problem, and start putting things into the box. But you'll start noticing pretty quickly that something weird is happening. First off, when we put the 60x to the third here, well, we haven't factored with an x to the third before, right? Usually that is an x squared. Then when we put the negative 260x down here, well, normally that doesn't have an x in that box. So already it looks a little bit different. And then when we start to use this table and we think about our multiplication, we are going to have to find something that multiplies to 60 times 260, and I don't even want to think about what that equals. So we have some really big numbers, and we also have some x's in places that shouldn't have x's. So when we see a problem like this, what we want to check and see if we can do is factor out the GCF first to make it a little bit simpler for us. So the process we're going to follow today is we are going to start with factoring out the GCF, which involves finding the GCF. All right, this is what we did in 7.4. So if you need to reference your notes, that would be a great idea. And then we're going to divide each term by the GCF. And this is where we're left with that factored form where we have the GCF on the outside and then what we call the leftovers on the inside. Okay? Once we get that, we are going to take a closer look at these leftovers. These leftovers today are most likely going to be something that we can use the box in order to factor more. So step 2, we are going to factor the leftovers using our table and our box method of factoring. And our final answer then is going to look pretty crazy. It's going to have a GCF in front. That's what we factored out in step 1. And then we're going to have our factors that we get from our leftovers. So these are called the factored leftovers. All right, so let's try a problem just to make sure we can actually accomplish this. So the problem we're going to start with today is 3x to the third plus 15x to the second minus 18x. So step 1, we have to actually find the GCF. So I'm going to think about the factors of 3. So 3 is 1 times 3, and that's it. So I'm going to think about, can I divide 3 into all of my numbers, 3, 15, and 18? And yes, I can. So our GCF is going to contain a 3. Then I'm going to think about the smallest power of x that we have, which is an x. So our GCF is 3x. I'm then going to divide every single one of my terms by 3x. And if this is what we were doing in 7.4, we would write our GCF out in front and then what we are left with on the inside once I do my division. As a reminder, we break our division down into little pieces. So for instance, in this first term, I would do 3 divided by 3, which is 1. And then I would do x to the third divided by x to the first, which is going to give me x to the second. Then in the second problem, I'm going to do 15 divided by 3, which is 5. I should say second term. And then x to the second divided by x to the first is just x. And then in the last one, I have negative 18 divided by 3, which is negative 6. And then here, my x's will end up just going away because they have the same power on the top and the bottom. So this is my GCF, and these are my leftovers. What you'll notice is the leftovers now are a quadratic. Quadratic, spelling is hard. A quadratic means it's a degree 2. So we have that power of 2, which is a good sign that we can use a box. So we're going to continue on in our notes, and we're going to be on this right-hand side. This is just a continuation of the problem that we did earlier. So our leftovers were x squared plus 5x minus 6. These were our leftovers. So now we are going to use the box in order to continue factoring these. I'm not even going to worry about my GCF anymore. I'm just going to do exactly what I know how to do with the box. So I need two numbers that multiply to 1 times -6, which is -6, and they have to add to my b value, which is 5. I'm going to think 1 times 6, 2 times 3, and then I'm going to have to worry about my positives and negatives. If I want to add to a positive, my bigger number needs to be positive. So I'm going to turn these little numbers negative. And then when I add -1 plus 6, I end up getting that 5. So my magic numbers are -1 and a positive 6. I'm going to put those inside my box, and then I'm going to work on getting outside my box. X times x, -1, positive 6. So the factors I get from my box are x minus 1 and x plus 6. But now I can't forget that in the very beginning of the problem, I factored out that GCF of 3x. So I need to include that in my final answers. All three of these pieces are factors of our original problem. Let's look at the example we have here on the left. Try this. So first we're going to find the GCF. So again, one more example here. We're going to list out factors of 12. 1 times 12, 2 times 6, 3 times 4. I'm going to start with 12 and say, can I divide 12 into 30? No. Can I divide 30 by 6? I can. Can I divide 18 by 6? I can. So 6 is a part of my GCF. Then my smallest power of x between these three powers is x to the second. So my GCF is 6x to the second. I'm going to divide all of these terms by 6x to the second so I can find my leftovers. So my my first factored form is going to be 2x to the second. That's what I get when I divide those two. Then I'm going to get -5x. And then lastly, I'm going to get -3. The inside are our leftovers, and these are what we are going to try to factor using the box. So I'm going to continue this process, oops, wrong pen, by setting up my box. And I'm only going to worry about the leftovers. So 2x squared and -3. I will need two numbers that multiply to -6, but add to -5. 1 times 6, 2 times 3. Wow, this happens to be almost the exact same problem as before. I will this time need a +1 and a -6. So I get a 1x and a -6x. I'm going to work on getting outside of the box. Going a little fast here because we've done a lot of these. And my factored form for just the box would be this. But we need to remember that way back in the beginning of the problem, we factored out that GCF of 6x squared. So my final answer is 6x squared at 2x plus 1 and x minus 3. Okay, we're going to do one more example together just so that I can hit on one more important fact that in some classes we hit on pretty hard and in other classes we just glanced through, so just based on time. So in this one, you'll notice that we have a negative in the very, very front of our polynomial. I'm going to work on finding the GCF. Okay, just like I have before. And I think I can confidently say that 7 goes into all of those. And then they all have an x. I'm not going to include a y though, because this last term does not have a y. Now, when I divide all of these terms by 7x, something kind of interesting happens when I write my factored form. I'm going to be left with a -6y to the second. The 7 and the x cancel, so then I'm just left with a y. And then a 7 divided by 7 is a 1. Okay, now, if I wanted to use the box on this, I could, but traditionally when we use the box, we don't want to have that negative in that very first box. So I'm going to go back because we do not want this negative sign here. This is not proper mathematics. So instead of factoring out a 7x for my GCF, I am going to make my GCF a negative 7x. And what happens when I do that is my negative 6 is going to turn into a positive 6. My positive y will turn into a negative y, and my positive 1 will turn into a negative 1. This is much more proper, a proper way of writing it where we have a positive number in front in our parentheses. So I'm going to continue by factoring my leftovers using the box method. So a times c is negative 6, and multiply or add to get negative 1. A lot of 6's today. 1 times 6 or 2 times 3. This time I need to add to a negative 1, so I want my bigger number to be negative. So my magic numbers are 2 and negative 3. You'll notice I almost wrote an X there. I've been trained to always write X's, so be careful. Now to get a 6, I'm going to need a 2y and a 3y, and then I will need a positive 1 and a negative 1. So my box factors are 3y plus 1 and 2y minus 1, but don't forget that GCF out in front, negative 7x. So our final answer has to have that GCF first and then the factors of our box. Hopefully that helps you today. You should have a 7-6C Savas assignment that you can work on, as well as the extra practice problems in the back of your note packet. Have a great weekend.